Assalamu alaikum. So the lesson today is about quadratic function and its graphs. So the lesson today is a continuation of the previous lesson, which is the quadratic function and its graph introduction. So we are going to apply what we learned on that lesson. So but before we start, let's summarize what we learned last time. So let's put a summary, then we will learn how to apply what we did last time. So given a function, quadratic function f of x equal ax squared plus bx plus c. So first thing you need to do is the first thing you need to do is find the discriminant. So which is b squared minus 4ac. So we will see the importance of the discriminant in the graph. So this is the discriminant of the quadratic. So like I said, first thing you need to define is your domain, and we already know that the domain of any polynomial function or quadratic functions is equal to minus infinite to infinite. So this is always the domain. So the second thing we need to look for is the vertex, which is defined by minus b over 2a because it's a point, it has two coordinates. The x-axis is minus b over 2a and the y-axis is minus the discriminant over 4a. A again is just a and b and c are those constants we use here. The third thing we need to find is axis of symmetry, and we already learned that the axis of symmetry is the x coordinate of the vertex. So x will be minus b over 2a. The fourth steps is define what is my range, and the range, like I said last time, is depend on a, if a is positive or a is negative. So if a is positive, then the range will be minus d over 4a, which is the y coordinate of the vertex of the vertex to the infinite. And if a is negative, the range will be from minus infinite to the y coordinate of vertex. And we on cavities, so we already defined that concave down, a greater than 0, concave up, down. And the last thing we talk about is the intercept. So is always the point 0, c, which means x equals 0 and y is c, and c is the constant coefficient. So if I remember, f of x is equal to ax squared plus bx plus c, and this is the c is that number. So let me write it in different color. So this is the c, and this c is always your y-intercept. If you have no c, that means it's 0. 0 is your y-intercept. For the x-intercept, so it depends about the discriminant. If the discriminant is less than 0, that means there is no x-intercept. So then no x-intercept. So in that case, what happened? Either the graph is above the x-axis or below the x-axis. So either if A is positive, that means the graph is above the x-axis. So the graph will look like this. If A is negative, then in that case the graph will be below the x-axis, going to look like this. So this is the two cases. If you have no x-intercept, either is above or below. The second case, if d is equal to 0, so in that case you have only one x-intercept, then there is only one x-intercept. Only one x-intercept, and it's going to be the x value of the x coordinate of the vertex, which is x equal minus b over 2a. So this will be your x-intercept, and again we follow the same concept of a positive is above or below for that one. But here the graph will look like this. So if this is my x and my y, so the graph will look like this, for example. So it's going to touch the x coordinate, x axis in one single point. So the last case, if d is greater than 0, in that case we have two x-intercepts. Then there are two x-intercepts. And those two x-intercepts are x equal minus b plus square root of the discriminant over 2a, or not or is and, because we have both, it's not one of them, it's both of them, and x equal minus b minus square root of the discriminant over 2a. So those are my two x-intercepts, and the graph will look like either that way if a is positive, or it's going to look like that way if a is negative. So either way, you're going to see the graph cut the x-axis into 2 points when the discriminant is positive. So those are the steps we learned last time. So now let's apply those steps in uh, in a function. So let's do an example. So those are examples. So this is the part of the example. So for example, let our graph this function. Graph f of x equal. So let's pick random function. So for example, 2x squared minus 5x plus 3. Like I say, let's read how the graph look like before I graph it. So let me take my discriminant. So the discriminant is b squared minus 4ac. You see this is my a, this is my b, this is my c. So I will end up having 25 minus 24, which is 1 greater than 0. All right. So here greater than 0, that means I have two x-intercept. So I have two x-intercept. So 2x-intercept a equal to is greater than 0. You see what I'm doing here? I'm doing discriminant and I'm looking for a. So now I know how the graph look like. I have two x-intercept. The graph is facing up, is concave up, and we have a minimum point. So this is a random graph. How it should look like for that type of function. Normally it should look like this. So this is how the graph will look like. I will have two x-intercept. I have concave up, and the minimum is somewhere here. So you see now, I already picture my graph, how it's going to look like. That means when I apply the steps to graph it, it should look like this. If it doesn't look like this, or if it's flipped, doesn't mean I made a mistake on my steps. So let's now do the graph. So f of x, let me write down the graph here. F of x is equal to x squared minus 5x plus 3. So I already know my domain is, you see, my domain is minus infinite to infinite. So I already know that, which is all the x-axis. So this is my x-axis, and this is my y-axis. So this is 1, 2, 3, and so on. 1, 2, 3, minus 1. So you already know the idea. So now what is my vertex? So I know that this is my first steps, is my domain. My second is the vertex. So the vertex, we already know that the discriminant is 1. So let me write down the formula. It's minus b over 2a minus d over 4a. So here it's going to be 5 over 4 because minus b is plus, and we have 2a, that means it is 4, and we have minus 1 over 8 because a is equal to 2 here. So this will be my vertex. So in my graph, so I'm going to try to show you where I will put my vertex. So the x-intercept is 1.2. Yeah, it's almost like 1.25. So this is 1, this is half, so it's almost like 1/4 here. So this is the x. So the y is minus 1/8, so it's going to be somewhere here. So let's assume it's here. So this is going to be my vertex. So I will name it 5, 4, and minus 1 over 8. And axis of symmetry is always the x coordinate. So this is axis of symmetry. So 3 is my axis of symmetry, which is x equal 5 over 4. So I'm going to draw it right now. So it's going to be the line that passes through that point. So I will draw it like this. So this is going to be my axis of symmetry. Let me name my axis of symmetry. This is x equal 5 over 4. Always name your axis of symmetry. The fourth steps is my range. So I already know that the range will be defined by minus 1 over a to infinite because a is positive. So the range is going to be from that point up. So there's nothing will be drawn down here. Is concave up because a is positive. So a positive is greater than 0. Concave up. I have 3 is my y-intercept. Y equal 3 y-intercept. I have plus twice, which is 4. So it's going to be 6 over 4, which is x, and that will be 5 minus 4 over 4, which is 1. So my x-intercept is very half. So it's very draw it now. So so this is my one. Let me use so its color number 3. Okay, and it's this. So let me draw it and do graph the other side. Here we see now I extend phone with symmetry. Uh, it's like make somewhere here. So it's gonna look like this. So this is how a V curve. It's not an angle. It's a curve. It's look like this. A V. A function a graph f of x equal example uh, minus example. So again, let me start with my discriminant, which is b squared minus 4ac. So which is 16 plus 20, which is 36. So this is positive. So we know that a equal minus 1 is less than 0, which means that the graph is concave down. The discriminant is positive, so my graph will look like this. That means I will have 2x-intercept because the discriminant is positive. A is negative, is concave down. So this is how the graph will look like. Now let's graph this. Okay, let me get the grid. To my axis. So all right. So let's write my function here, and so my function f of x is minus x squared minus 4x plus 5. So again, my domain is minus infinite to infinite. My discriminant, which is d b squared minus 4ac, we already find out is 36. So what's going to be my vertex? Vertex is, let me write down the formula for you guys again. So minus b over 2a and minus d over 4a. So it's going to be minus b. So it's going to be 4 over minus 2, which is going to be minus 2. And minus 36 over 4 times minus 1. So it's going to be 36 over 4, which is 9. So now let me, so this is minus 2. The x coordinate is minus 2 here. And what is 9? This is 2, 4, 6, 8, 9. So this is the location of my vertex, which is minus 2, 9. So my axis of symmetry, x equal minus 2. So this is going to be my axis of symmetry. So my range is going to be from minus infinite to 9. So this is going to be my range, minus infinite to 9. And I know that it's concave down because a is negative. A equal minus 1 less than 0, so it's concave down. So my y-intercept is 5. Y-intercept is 5, so which is 2, 4. So this is going to be my y-intercept. Intercept 4 plus square root of 36, which is 6 over uh, uh, 10 over minus 2, which is 1, and my second one is, let me use here, so it's going to be 4 and 6. Now let me draw my axe of symmetry. The yeah, the what you call, like, I can draw my graph. So I draw. So let's redo it. Let me show you an idea. You see, if I the uh, if I copy it and I paste it and I flip it, I should get I like to use type of, there we go. And this is the idea. I hope you see how it works. So let's another example. For example, I want to graph f of x equal x is 4 squared minus 4 times 1 times 6, which is 16 minus 24, and this is equal minus 8, which is less than 0, which means that there is no x-intercept here. So there is no x-intercept, and a equal 1 greater than 0. That means the graph is above the line. It's going to look like this way. So we are going to see how to graph that type of graphing. So let's graph it here. So let me get my grid first. All right, so my function is the following. So f of x equal x squared plus 2x plus 6. So I know my domain is always minus infinite to infinite. So my vertex So it's minus 1, 5. My axe of symmetry x is equal minus 1. So let me draw it here. So this is my axe of symmetry here. X equal minus 1. So let me name it x equal minus 1. And we know that the range is 5 to infinite because a is positive. So range is from 5 to infinite. And we know it's concave up because a is equal to 1. So a equal 1. So concave up. So it's going to look like up here. And the y-intercept is y equals 6. So 2, 4, 6. So this is my y-intercept. And my vertex is minus 1, 5. So minus 1, 5. So it's here. This is my vertex. Minus 1, 5. Now I have no x-intercept, so no x-intercept again. So what I do here, I just graph one side, and I do by symmetry to graph the other. Let me redo it. Now what I do here, I just copy, paste, and I just flip by symmetry. You see, you just need to do just by symmetry. You can graph the second side, and this will be your graph of that function if if you have the type of function without x-intercept. Just graph the side where there is the y-intercept, and by symmetry you can produce the other bar. So I hope you got the idea. In terms of negative, if it's going down, it's going to be the same concept. You graph the side with the y-intercept, and you produce the other side by symmetry. So I hope you understand uh, the main concept about how to graph a quadratic function or a parabola. So please, if you have any comments about the way I teach or how I present my lesson, please do so. It will help me improve my way of teaching. And thank you very much for watching the video. Assalamu alaikum.